Welcome to the deep dive. Today we're plunging into a topic that's, well, it's not just making headlines, it's actively reshaping our world. Generative AI. It feels like this technology just burst onto the scene in the last year or so, right?
Yeah.
Transforming everything from how we create art to how we write code.
It really does feel sudden.
But as we'll discover today, the story of generative AI is far richer. It actually stretches back not just years, but decades. It's filled with, forgotten breakthroughs and some surprising detours.
Absolutely.
We'll be navigating this with insights from a fantastic foundational guide, Generative AI, Novice Introduction. And we're going to use it as our compass to move beyond the headlines and really truly understand this transformative field.
And what's truly compelling about this moment isn't just like the arrival of a new gadget or piece of software. It's really the dawning of a fundamental shift in how humans and machines can interact.
That's a great way to put it.
Yeah, and this guide, it offers a remarkably clear roadmap. It helps us distinguish between the genuine, the profound impact of generative AI and maybe some of the more sensationalized hype. It helps us grasp the core why behind its rapid integration into, well, nearly every aspect of our lives and work.
Okay, so let's begin by grounding ourselves in what exactly generative AI is. Because for decades, AI was largely about analysis, right? Finding patterns or executing predefined tasks with incredible speed.
Right, analyzing or classifying.
But generative AI marks a distinctly different leap. It feels like it's moving us from mere calculation to genuine creation, from interpretation to something that, feels kind of like imagination, what's at its core.
Yeah, that's the key shift.
Huh.
At its core, generative AI, or GenAI as it's often called, is a type of artificial intelligence designed specifically to create novel, original content.
Okay, novel and original.
That's the critical distinction. It's not just recognizing a cat in a picture, which older AI could do. It's inventing a cat that has never existed before. And this creation, it can manifest in just countless forms. From crafting a sonnet in the distinctive style of Shakespeare, to writing functional software code, or even rendering a photorealistic image that is entirely new. It's a truly new paradigm for how we interact with machines.
And the way we interact is different, too. It's through something called a prompt. Correct. It's not like traditional software where you're just clicking buttons or filling out forms.
That's exactly right. The interaction is almost entirely prompt-driven. You, the user, provide a request, typically in natural language. I mean, you just talk to it or type to it like you would another person.
Just speak normally.
Yeah. And this request can be super simple, like write me a poem about a sunrise, or it could be incredibly detailed, a complex command describing specific characters, settings, artistic styles, you name it.
You can even give it an image sometimes.
You can. You can upload an image as part of your request, too. The AI then interprets that prompt to generate its response. And this back and forth, this iterative process of refining the output based on your prompts, that's crucial. It's what makes the interaction feel, well, almost like a collaboration.
And the sheer range of what these systems can produce is just astonishing. We're definitely not confined to just text anymore. The source material highlights a whole spectrum of modalities, as they call them.
Absolutely. That astonishing range of outputs really underscores its versatility. I mean, for text-based models, okay, you can ask them to draft a marketing email or condense a really dense scientific paper into a concise summary, maybe generate a functional piece of computer code. Standard stuff, almost.
Right, the kind of thing we're getting used to.
But the capabilities extend so far beyond that. Image-based models can instantly transform a description like a photograph of an astronaut riding a horse on Mars into a stunning visual, or create a unique logo for a coffee shop in a minimalist style. And the innovation doesn't stop there. Other generative models can compose entirely original music,
Wow.
generate incredibly realistic voiceovers that mimic human speech, or even create short, high-quality video clips from just a simple text description.
So this isn't just a fancy search engine retrieving existing information then. It's truly building something new from scratch.
That's the fundamental characteristic we really need to grasp. The system isn't retrieving a pre-written answer from some database or pulling up a stored image, no. Instead, it's synthesizing something entirely new.
Synthesizing, I like that word.
It achieves this by learning the underlying statistical patterns, structures, and relationships within the enormous datasets it was trained on. Then, drawing upon that learned knowledge, it produces artifacts that are statistically consistent with the training data, but are, in fact, entirely novel creations. It's a leap from simple data processing to genuine content generation.
Okay, so when we talk about generative AI, it helps to place it within the larger family tree of artificial intelligence,
Yeah.
because we've long been familiar with what's often called narrow AI, haven't we?
Yes, that's a great way to put it. Think of the broader field of AI as like a sprawling tree with many diverse branches. Generative AI is certainly the newest and probably the most talked about branch right now.
For sure.
But it didn't grow in isolation. Historically, the most common form has been what we often refer to as traditional AI, or sometimes narrow AI or weak AI. These systems are designed to perform very specific, predefined tasks based on a rigid set of rules or algorithms.
Like the spam filter in your email inbox, maybe, or the recommendation engines on Netflix and Amazon.
Mhm.
They're incredibly useful, super efficient, but they do one thing really well within very defined boundaries.
Exactly. They excel at classification, decision-making, or executing specific actions. A spam filter classifies messages, legit or junk. A recommendation engine suggests content based on your viewing history. Even voice assistants like Siri and Alexa, while they seem sophisticated, they really just respond to a limited set of commands within a programmed domain.
Right, they don't really understand in a broad sense.
Precisely. Their core strength lies in analyzing and interpreting existing data for efficiency or accuracy within those defined boundaries. The key question traditional AI answers is always something like, is this A or B, or perform task X? They are highly effective at automation, but lack the flexibility to operate or, importantly, create outside their programmed parameters.
Gotcha. And then there's predictive AI, which is also a huge part of our digital lives, often working silently in the background.
That's right. Predictive AI is another incredibly powerful and, frankly, ubiquitous branch. It primarily uses machine learning techniques to forecast future outcomes based on analyzing historical data.
Okay, forecasting.
Yeah. These models are designed to identify patterns and correlations in past events to make statistically informed predictions about what's likely to happen next. It's the engine behind, say, credit scoring systems, determining your credit worthiness,
Wow.
or how retailers forecast demand for products, or even healthcare algorithms that predict a patient's risk of developing a certain disease. The fundamental question predictive AI answers is, given what has happened in the past, what is likely to happen next?
So if predictive AI tells us what's likely to happen based on the past, generative AI is about making something entirely new that fits those learned patterns from the past. Is that a fair way to think about it?
That's a crucial distinction, yes, and it highlights the leap generative AI takes. While it also learns from historical data, its purpose isn't to forecast a single future value or classify existing data. Its purpose is to create entirely new data points that are statistically consistent with the training data. It answers the command, make a new thing, based on these examples you've learned from. So, to give you a concrete example, a predictive AI might suggest a common predefined response to a customer service email, like, thank you for your inquiry. But a generative model, like ChatGPT, can analyze that same email and compose a completely new, detailed, multi-paragraph response tailored to the specific context, maybe including specific product info or follow-up questions, all generated fresh.
Right. It's not canned.
Not at all. Or think about this. A predictive AI model might forecast the success of a marketing campaign. A generative AI model could actually create the text and images for the campaign itself.
Wow. Okay. That distinction, automation versus augmentation, this really changes how we think about AI in our daily lives, doesn't it? It's not just doing things for us, but increasingly with us. That's a profound difference.
It is indeed a profound difference, and it's perhaps the most significant implication for you, the listener, right now. Traditional and predictive AI are primarily tools of automation. They're designed to execute a human task faster, more accurately, or at a greater scale, often operating sort of autonomously in the background. A spam filter just works.
Set it and forget it.
Exactly. Generative AI, however, is increasingly framed not as pure automation, but as augmentation. The language we even use to describe it reflects this. It's a creative assistant, a collaborative partner, a co-pilot.
Mm-hmm.
The user actively interacts with these systems, guiding them with prompts, refining outputs, directing their creative flow to enhance their own capabilities. For instance, a writer uses a language model to overcome writer's block, not necessarily to replace their writing entirely.
Right. It's a tool.
It's a tool. A designer uses an image model to brainstorm visuals, speeding up their ideation phase. A programmer uses a code generator to accelerate development, not to take over their entire job. The AI doesn't replace the human, it works with the humans, significantly augmenting their creative and intellectual reach.
So the implications for work, They're huge.
Profound implications for the future of work. While some tasks might be fully automated, the more immediate and widespread impact will likely be the transformation of existing jobs. It demands entirely new skills in human-AI collaboration, in critical evaluation of AI-generated content, and, crucially, in the art of crafting effective prompts to guide these powerful new partners.
Yeah.
And this raises an important question. How do we prepare ourselves for this shift? Going from tasks being done by AI to tasks being done with AI, it really requires a different mindset, a different skill set, emphasizing oversight, discernment, and creative direction.
That's great lead-in, because if it's creating and augmenting like this, it must have some kind of mind or process to actually do it. So how does this magic actually work? How does it even begin to learn to create?
Yeah, to the uninitiated, the capabilities of generative AI can certainly seem almost magical. But in reality, they're the product of incredibly sophisticated mathematics, immense computational power, and a series of architectural innovations developed over decades. Demystifying this process is really key to understanding both the incredible capabilities and, just as importantly, the inherent limitations of generative AI.
Okay, so what's the fundamental starting point? How does it even begin to learn anything at all? Where does it start?
Generative AI systems are built on the bedrock of machine learning, ML. That's the field that enables computers to learn from data without explicit programming for every single rule.
Right, learning from examples.
Exactly. Specifically, they primarily utilize a complex type of machine learning architecture known as a neural network. These networks are, well, very loosely inspired by the interconnected structure of neurons in the human brain. They feature layers of digital neurons that process and transmit information. This layered structure allows the model to learn incredibly complex patterns and relationships hidden within vast datasets. The learning process itself is called training. During this phase, the neural network is exposed to truly astronomical amounts of data.
Astronomical. Like how much?
We're talking massive scale. For a large language model, LLM, like the ones powering chatbots, this might be a significant portion of the publicly available internet. A colossal corpus of books, articles, websites, conversations, just vast amounts.
Wow.
For an image generation model, it could involve billions of images paired with their corresponding text descriptions.
So it's not actually thinking or reasoning like a human, is it?
No.
It's more like it's learning statistical patterns from virtually everything humans have ever created and put online. That's a huge distinction.
It is a critical distinction. It's all about statistical relationships and patterns, not consciousness or understanding in the human sense. The sheer scale of data is what gives it this apparent intelligence and versatility. And because these models are trained on such broad, generalized data sets and can then be adapted or fine-tuned for many different downstream tasks, they are often referred to as foundation models, FMs. LLMs are simply foundation models specialized for processing and generating human language.
Right.
The scale of these models is just difficult to comprehend. They often involve billions or even trillions of parameters, which are the internal variables the model adjusts during training to capture all those intricate patterns in the data. Think of each parameter as like a tiny dial the model tweaks to perfectly map input to output based on what it learned.
Trillions.
Yeah.
That's wild. Okay, so it's trained on a colossal amount of data, tweaking these billions, maybe trillions of parameters. But then once it's learned all this, how does it actually create something new? How does it move from just recognizing patterns to generating a brand new poem, for example?
Right. So once it's trained, the core mechanism is essentially a highly advanced form of pattern matching and statistical prediction. At its heart, an LLM functions as a probabilistic prediction engine.
Probabilistic prediction.
Okay. When asked to generate text, for example, its fundamental task is to predict the next most likely word, or token as it's technically called, given the sequence of words that has come before it. Think of it like your smartphone's autocomplete function, but one that has read nearly the entire internet and understands grammar, context, facts, stylistic nuance, all that stuff, on a scale we can barely imagine.
So if you type, the first person to walk on the moon was, it doesn't just look up Neil Armstrong in a database somewhere.
Yep.
It's actually calculating the statistical probability that Neil is the next word, and then Armstrong after that, and so on.
Exactly. Neil will have a very, very high probability of being the next word in that context, while a word like, say, cheese will have a probability close to 0. Hopefully. The model selects a word based on these probabilities, adds it to the sequence it's building, and then just repeats the process, predicting the next word based on the now extended sequence. By stringing together these predictions one token at a time, it can generate coherent sentences, paragraphs, even entire documents.
Okay, but how does it keep track of context over long stretches? Older systems used to forget what you said a sentence ago.
Ah, that's where a massive breakthrough comes in. This sequential prediction process was profoundly revolutionized by an architecture introduced by Google researchers back in 2017. It's called the transformer.
The transformer, heard that name a lot.
You probably have. It's foundational. Before the transformer, models processed text sequentially, like reading a book word by word, right? Which made it incredibly difficult for them to maintain context over long passages. They'd just lose the plot. The transformer architecture, however, changed everything. It can process all the tokens in a prompt simultaneously. It achieves this using a powerful mechanism called attention, or more specifically, self-attention. This allows the model to weigh the importance of every other word in the input when considering the next word to generate.
So it's looking at the whole picture at once.
In a sense, yes. It gives it a much more holistic understanding of context, enabling it to produce the remarkably coherent long-form text that characterizes modern LLMs. That's why you can have a complex back and forth with something like ChatGPT, and it generally remembers what you were talking about 5 turns ago.
Okay, so what this means for us, the users, is that it's not copying. It's navigating this kind of map of ideas and patterns to generate something new. And this attention mechanism is why it can keep track of longer conversations. That's a pretty elegant way to put it.
It is. And for you, the user, what this means is that modern LLMs can finally understand nuance across long conversations or documents. It allows for truly coherent, detailed responses that previous models just couldn't manage.
Why?
And crucially, the model doesn't simply memorize and stitch together sentences or images from its training data. That's a common misconception. Instead, during training, it learns a compressed, abstract representation of the data. This concept is known as latent space. You can think of this as like a high-dimensional map where similar concepts are located incredibly close to one another.
Like a map of ideas.
Sort of, yeah. For instance, the mathematical relationship or vector between king and queen in this space would be very similar to the relationship between man and woman. It learns the fundamental features and relationships that define the data.
Okay.
So generating new content, then, is not an act of retrieval like searching. It's an act of navigating this latent space. The model samples a point from this abstract map and then decodes it back into a recognizable format, like a new sentence or a unique image, that shares the underlying characteristics of the training data, but isn't a direct copy. It's like having a mental blueprint for all possible cat images, and then drawing a new cat based on that blueprint, not tracing an existing one. Hashtag tag 2.3. Analogies to make it click.
These analogies really help demystify the magic a bit and give us a clearer picture of how these models operate. Let's dive into a few more that the source mentioned because they highlight both the capabilities and some of the fascinating limitations.
They do, and grasping these analogies is really fundamental to a full understanding. Let's begin by imagining the AI as an apprentice chef.
Okay, I like food analogies.
Me too. So this chef has spent years in the world's most comprehensive culinary academy, meticulously memorizing every recipe from a vast global library of cookbooks. That's our huge training data.
Right.
Now, when you, the customer, walk in and provide a specific request, maybe for a unique dish combining unexpected ingredients, that's your prompt. The chef doesn't just pull out an existing recipe from memory. Instead, drawing on their immense internalized knowledge of flavor pairings, cooking techniques, presentation styles, they invent an entirely new dish designed to satisfy that specific request. It's creation based on learned patterns and principles, not just rote memorization.
That's a great way to visualize it. So it has all this knowledge, but it puts it together in new, original ways based on the request.
Exactly. Another useful analogy is the statistical librarian. Imagine a librarian who has somehow read every single book in the world's largest library.
Oh.
Yeah. They haven't memorized each book verbatim, but they've developed an incredibly profound statistical understanding of how words, sentences, concepts, and even narrative styles relate to one another. If you ask them to write a new paragraph about, say, space exploration, but in the distinct style of Ernest Hemingway,
Okay.
they can do it effortlessly, not because Hemingway ever wrote about space, but because the librarian has learned the statistical patterns of his prose, the typical sentence length, the characteristic vocabulary, the rhythm, the tone, and can apply those abstract patterns to a brand new subject. It's all about the statistical relationships, not the direct content.
And then there's Ted Chiang's blurry JPEG of the web. analogy, which I find particularly fascinating. It seems to get at where things can sometimes go wrong.
Yes, that analogy, coined by the computer scientist and author Ted Chiang, perfectly captures both the immense power and the inherent peril of generative models. Think of it this way. Like a JPEG image file compresses a high-resolution photograph into a much smaller, manageable file size.
Right, you lose some detail.
Exactly, it's lossy compression. A generative model is similarly a compressed, lossy representation of its vast training data. It retains enough crucial information to reconstruct a plausible version of the original, but it doesn't have a perfect pixel-for-pixel copy.
Okay.
In this process of compression and subsequent reconstruction, fine details can inevitably be lost, and the reconstruction itself can introduce what we call artifacts or errors. In the context of AI, these errors are commonly referred to as hallucinations.
Ah, the hallucinations. We hear that term a lot.
We do. And this helps explain why models can seem so knowledgeable and articulate, yet at times they are prone to confidently making things up or getting facts fundamentally wrong. They're not accessing a perfect, verifiable truth from a database. They're generating a statistically plausible reconstruction of information, and sometimes that reconstruction includes plausible-sounding fabrications.
That makes so much sense. So if it's essentially hallucinating sometimes, just relying on statistical plausibility, how do we as users ever fully trust its output, especially in high-stakes areas like medicine or finance? And how do the developers even try to rein that in?
Your question goes right to the heart of the matter. This is precisely where the human in the loop becomes incredibly important and reveals a deeper truth about these systems. The training process for these models doesn't simply end after their initial exposure to massive data sets.
Okay, there's more to it.
There is. To make these models more useful, more reliable, and crucially safer for public consumption, they undergo further refinement. One common technique is fine-tuning. This is where a pre-trained foundation model is trained further, but on a smaller, more specialized data set. For example, a general language model might be fine-tuned on medical research papers to become a more specialized medical assistant, or on legal documents for legal analysis, makes it better at specific tasks.
But I've heard a lot about something called RLHF, reinforcement learning from human feedback. That sounds like it's really critical for the conversational models like ChatGPT that we use every day, right?
Absolutely. Reinforcement learning from human feedback, RLHF, is perhaps the most pivotal refinement technique right now, and it's largely what gives models like ChatGPT their helpful, conversational, and generally well-behaved tone.
How does that work?
Well, the process is quite ingenious. After initial training, the model is prompted to generate several different responses to a given query. Human reviewers then evaluate and rank these responses from best to worst based on a set of criteria, things like helpfulness, factual accuracy, harmlessness.
So humans are rating the AI's answers.
Exactly. This human feedback is then used to train a separate reward model, which basically learns to predict which responses humans prefer. The generative model is then further trained using reinforcement learning techniques to maximize its score according to this reward model. In essence, it's rewarded for producing outputs that are more aligned with what the human raters preferred.
Interesting.
This iterative process of feedback and reinforcement is crucial for shaping the model's behavior, making it more useful, safer, and aligning it better with, well, human values and expectations.
So these models are not just objective knowledge engines then. They're fundamentally shaped by human preferences and values through this feedback loop. That implies a much deeper truth about them, doesn't it?
It does.
Yeah.
And this entire process, from training on vast cultural data to compressing it into a latent space and then refining it with human feedback, it reveals a profound truth about this technology. Generative AI models are not objective machines that have discovered some universal, immutable truth. They are, in essence, powerful, statistically driven cultural mirrors.
Cultural mirrors.
The output they generate is a reflection of the collective knowledge, language, art, and, critically, the biases embedded within their training data. The model learns from the web, and the web is a product of human society, warts and all.
Right. All our biases are online too.
Exactly. Therefore, if the training data contains stereotypes, misinformation, or cultural biases, the model will inevitably learn and reproduce them, sometimes even amplifying them in the process. That latent space we talked about, it's not a map of objective reality. It's a compressed map of human cultural output.
Wow.
This means that the challenges of AI bias and fairness are not mere technical bugs to be patched. They are deep-seated societal issues reflected back at us by our own creation.
So users need to be really aware of this.
Absolutely. For any user, moving from being a novice to a critical thinker requires understanding that the output of a generative model is not a statement of fact. It's a statistically plausible recombination of the human culture on which it was trained.
Hmm.
And this raises an important question, doesn't it? If these models are reflections of our own data, what responsibility do we have collectively in curating that data, and even more importantly, in critically evaluating the reflections they show us? This human in the loop isn't just a technical detail, it's a profoundly ethical and societal consideration.
That's a powerful thought to carry forward, and it truly anchors us in the reality of this technology. Because while ChatGPT felt like an overnight phenomenon, the source makes it clear the story of generative AI is far richer, stretching back not years, but decades. It's a journey filled with, like you said, forgotten breakthroughs and surprising detours. Wouldn't you agree?
Absolutely. The sudden explosion of generative AI into the public consciousness, late 2022, triggered by the viral launch of ChatGPT, it can indeed give the impression of an overnight revolution.
Yeah.
But in reality, this moment was the culmination of over 70 years of relentless research, a long and arduous journey characterized by brilliant scientific breakthroughs, periods of intense optimism and grand pronouncements, and then, well, crushing winters of disillusionment and defunding.
The AI winter.
Exactly. Understanding this deep history is essential to truly appreciating the robust foundations upon which today's incredibly powerful tools are built.
Okay, so let's go way back to the very beginning. Where were the first seeds of what we now call AI planted?
The intellectual seeds for artificial intelligence were really sown in the mid-20th century, specifically during what we call the foundational era, roughly from the 1940s to the 1960s. In 1948, Claude Shannon, often called the father of information theory, published his landmark paper laying the mathematical groundwork for all modern communication and computation. Foundational stuff. This was quickly followed in 1950 by Alan Turing's seminal paper, Computing Machinery and Intelligence, which famously proposed the Turing test, also known as the imitation game.
Right. Can a machine fool a human into thinking it's human?
Precisely. This test, where a machine's conversation must be indistinguishable from a human's, established a philosophical and practical benchmark that would drive the field for decades. It really set the stage for what we now see with conversational AI.
It's truly incredible to think that the core ideas behind something like ChatGPT were being dreamed up almost 70 years ago, even before many of us were born.
It is, isn't it? The term artificial intelligence itself was officially coined by John McCarthy in 1956 at the legendary Dartmouth Summer Research Project on Artificial Intelligence. This workshop brought together the field's founding researchers and formally established AI as a distinct academic discipline.
So that's where the name came from.
That's where it came from. And in these early golden years, progress seemed remarkably rapid, and the ambition of the researchers was just boundless. The first glimmers of generative capability soon followed too. In 1965, Joseph Weizenbaum at MIT created ELIZA.
ELIZA, I've heard of that one, the therapist chatbot.
That's the one. A chatbot that used simple pattern matching and keyword substitution to simulate a Rogerian psychotherapist. While it was pretty rudimentary in its underlying mechanics, ELIZA was a sensation. It demonstrated for the first time that a computer could engage in a seemingly natural language conversation with a human.
And people actually talk to it.
Oh, yeah. Some people actually confided in ELIZA as if it were a real therapist, which really shows you how powerful the illusion of connection can be, even with simple rules. Simultaneously, other researchers were developing simpler statistical models known as Markov chains. These could perform very basic next-word prediction, a primitive, almost ancestral form of today's complex large language models.
So we had this exciting start, this golden age, but then came the infamous AI winters, which sounded a lot less fun. What happened? Why did things freeze up?
Well, the initial sort of unbridled optimism of those golden years soon collided with the harsh realities of limited computational power and, frankly, overly ambitious expectations. This led to periods of severe disillusionment and defunding, famously known as AI winters.
Okay.
The first AI winter descended around 1974 and lingered until about 1980. The core problem was that the hype had just completely outpaced the available technology. Researchers consistently ran into the wall of what was termed the combinatorial explosion.
Combinatorial explosion.
Sounds messy.
It means the computational requirements to solve real-world problems grew exponentially, just utterly overwhelming the limited processing power of the era's computers. Early AI systems could solve trivial, kind of toy versions of problems, but they consistently failed when faced with genuine real-world complexity.
Wow. This led to severe criticism, notably from the Lighthill Report in the UK. And in the US, DARPA significantly cut funding for broad exploratory AI projects. As the funding dried up, many research labs downsized dramatically, and the field entered, well, a deep freeze.
So, a classic case of overpromising and underdelivering, fueled by tech limitations. Did the field manage to thaw at all after that first winter, or did it just stay frozen?
There was a brief hopeful thaw in the early 1980s with the rise of something called expert systems.
Expert systems, okay.
These were innovative programs designed to capture the specialized knowledge of human experts in a very narrow domain, like diagnosing specific medical conditions or assisting with geological exploration for oil. Corporations invested heavily in these systems, and a whole new industry emerged dedicated to building and selling them. They often required specialized, very expensive computers called LISP machines to run them efficiently.
Right, I remember hearing about those.
But this boom was unfortunately short-lived. The expert systems, they proved to be brittle. They were difficult and costly to update with new knowledge, and they lacked the flexibility to adapt outside their pre-programmed domains.
Yeah, limited again.
Very limited. And the final decisive blow came around 1987 when the market for those expensive LISP machines collapsed. Cheaper and increasingly powerful general-purpose workstations from companies like Sun Microsystems could run LISP software just as effectively, making the specialized hardware obsolete almost overnight.
Ouch.
Yeah. This collapse triggered the second AI winter, an even longer and deeper period of widespread disillusionment that lasted from roughly 1987 right up to the mid-1990s. But, these winters, as tough as they were crucial learning periods.
How so?
They taught researchers invaluable lessons about the limitations of existing approaches and underscored the absolute importance of robust computational power and access to vast amounts of data, exactly the things that were missing. It set the crucial stage for the future breakthroughs that were still, decades away.
And that brings us nicely to the modern Renaissance. You mentioned these winters taught crucial lessons about needing compute power and data. So how did the field finally emerge from that deep freeze into the current boom we're seeing? It seems like, as the source suggests, a confluence of factors, almost a perfect storm, came together.
It absolutely was a perfect storm. The end of the AI winters wasn't due to a single isolated breakthrough. It was really the powerful convergence of three distinct forces that created the ideal conditions for innovation, kicking off around the 2010s and continuing to the present.
Okay. What were the three forces?
First, there was the explosion of massive data. The widespread adoption of the internet, the rise of social media, the rapid digitization of every aspect of society, it created an unimaginable treasure trove of data. Trillions of words of text, billions of images, countless hours of video and audio. This is the raw, unstructured material, the fuel needed to train complex machine learning models.
The fuel, right.
Second, we saw an exponential increase in computational power. And here's a fun fact. The video game industry, perhaps surprisingly, drove the development of incredibly powerful graphical processing units, GPUs.
For gaming graphics.
Exactly. Researchers quickly discovered that the parallel processing architecture of GPUs designed to render complex graphics in real time was perfectly suited for the massive mathematical operations required by deep learning. This provided the necessary computational muscle that had been missing during the AI winters. It made training these huge models feasible.
So gamers helped pave the way for AI.
In a very real sense, yes. And third, there were critical algorithmic breakthroughs. With abundant data and affordable compute power finally available, older theoretical ideas in neural networks suddenly became practical. And crucially, new, more powerful algorithms were developed and refined, making the models much more effective.
It's truly fascinating how all these separate threads, data, power, algorithms converge to give us this overnight success of things like ChatGPT. It really reminds us how often innovation isn't a single eureka moment, but the culmination of these long-term trends finally clicking together.
Indeed. And this powerful confluence of factors led to a rapid succession of pivotal breakthroughs. In 2014, Ian Goodfellow and his team introduced generative adversarial networks, GNs.
GNs, right, the ones that make realistic faces.
That's what they became famous for. They were truly revolutionary. Two competing neural networks, a generator that creates new data, like images, and a discriminator that tries to distinguish the generated data from real data. This adversarial sort of competitive process pushed the generator to produce astonishingly realistic and high-quality images. It completely transformed the field of image generation.
Okay, so that was big for images. What about language?
For language models, the most impactful breakthrough was undoubtedly the transformer architecture, published by those Google researchers in 2017.
There it is again.
Yeah, it's that important. Its self-attention mechanism was the real game changer. It allowed models to process entire sequences of text at once and, crucially, understand the contextual relationships between all words, no matter how far apart they were in a sentence or paragraph.
Ah, solving that long-range context problem.
Exactly. It finally solved the problem that had plagued earlier language models and became the foundational architecture for virtually all modern large language models. The shift allowed by the transformer architecture really just cannot be overstated for language models. It fundamentally changed what was possible in understanding and generating coherent, long-form text.
And this leads directly to the public explosion we've witnessed.
Yeah.
The moment generative AI truly broke through into the public consciousness.
Precisely. Building directly on the transformer architecture, the research lab OpenAI began developing its series of generative pre-trained transformer GPT models. With each successive iteration, GPT-2, GPT-3, GPT-4, these models grew exponentially larger and dramatically more capable. The release of ChatGPT in November 2022, built on these powerful models and made accessible through a simple, intuitive chat interface, was the definitive tipping point. It went viral at an unprecedented speed, attracting 1 million users in just 5 days.
Incredible.
It brought the transformative power of generative AI out of the academic research labs and literally into the hands of the general public. This ignited the current, seemingly sudden boom of investment, innovation, and widespread public fascination that we are experiencing today. The journey from Turing's initial thoughts to ChatGPT's viral success is truly one for the history books.
That historical journey really puts into perspective how long these ideas have been brewing. It wasn't overnight at all. But now let's turn to the practical side. What can these generative AI tools actually do for us right now? How are they being applied in the real world across different areas?
Yeah, having established what generative AI is, how it works, and where it came from, the focus now shifts decisively from the theoretical to the intensely practical. The true, tangible impact of this technology is best understood by looking at its concrete applications across a vast spectrum of creative and intellectual domains. This section of our deep dive explores the current generative AI toolkit, surveying how these models are actively being used to create everything from text and images to music and code, highlighting some of the specific tools that are defining each modality.
Okay, let's start with a revolution in language, because this is probably what most people think of first when they hear generative AI.
Yeah.
The ability to generate human-like text.
You're right. The capability to generate human-like text is arguably the most mature and certainly the most widely adopted application of generative AI today. Large language models, or LLMs, are fundamentally transforming how we write, communicate, and process information. They are acting as incredibly powerful, tireless assistants for just a vast array of language-based tasks, from the mundane to the highly creative.
So walk us through it. How are individuals and businesses actually using these new wordsmiths day to day?
There are several key, impactful uses. First, and perhaps most broadly, is content creation and augmentation. At its most basic, an LLM is a phenomenal writing tool. You can prompt it to draft entire articles, compelling blog posts, marketing copy for campaigns, professional emails, even social media updates.
The basics.
Right. But beyond simple drafting, it can augment your writing process by effortlessly adopting specific styles or tones. You can ask it to rewrite a formal report in a more casual, engaging style, or expand a simple bulleted list into a full, detailed paragraph, or even craft a piece of creative writing like a poem or a short story. This makes it an incredibly versatile tool for professionals across all industries, as well as for creatives.
And for dealing with the sheer information overload we all face every single day. So it's like a lifesaver for that.
It absolutely is. That brings us to the second key use: summarization and information extraction. LLMs excel at condensing vast amounts of information into manageable forms. They can take long, complex documents, dense academic papers, extensive news articles, or lengthy email threads, and instantly produce concise, accurate summaries. This saves users significant time and effort in research and analysis.
Yeah, I can see that being huge.
This capability is rapidly being integrated into productivity tools to help knowledge workers quickly get up to speed on projects, understand complex communications, or digest large volumes of data.
They've also fundamentally changed chatbots, haven't they? I mean, those frustrating rule-based ones seem to be finally giving way to something much more natural and intelligent.
Indeed, generative AI has truly revolutionized conversational AI. Older rule-based chatbots were often incredibly frustrating because of their limited scripts and inability to handle any nuance.
I'm sorry, I don't understand the question.
Exactly. Modern conversational AI, powered by sophisticated LLMs, can understand complex context, remember previous parts of the conversation for truly natural flow, and engage in free-flowing, dynamic dialogue. This has led to the development of highly sophisticated virtual assistants for customer service, capable of handling complex queries, providing personalized support, and resolving issues far more effectively. It profoundly improves the overall customer experience.
And for anyone who's ever faced that daunting blank page or writer's block, it sounds like the perfect brainstorming partner too.
That's the fourth crucial application, brainstorming and ideation. LLMs serve as tireless creative partners. When faced with a blank page or a difficult problem, you can engage the model in a dynamic dialogue to brainstorm a wide range of ideas, outline a complex project, explore different angles for a story, or generate multiple potential solution paths for a challenge. This collaborative process can effectively help break through creative blocks, expand your thinking, and significantly broaden the scope of what an individual or team might consider.
So whether you're battling writer's block or just drowning in emails or maybe trying to invent a new product, there's probably a language model out there that can help. It's truly like having a tireless assistant on demand. What are some of the popular tools in this space that our listeners might recognize or want to try?
Yeah, the landscape of language models is currently dominated by a few major players, though it's changing fast. ChatGPT from OpenAI is undoubtedly the tool that brought generative AI to the mainstream. It's renowned for its strong conversational abilities, remarkable versatility, and its pretty user-friendly interface.
The one everyone knows.
Right. Then there's Gemini from Google. As the creator of the underlying transformer architecture, Google is a formidable force. Gemini is designed to be multimodal from the ground up, and it's deeply integrated into Google's extensive ecosystem, from search to workspace apps like Docs and Gmail. Claude from Anthropic is another big one. Anthropic was founded on principles of responsible AI development, and Claude is gaining recognition for its complex reasoning capabilities, its unusually large context window, meaning it can process and remember massive amounts of text, and its strong focus on producing helpful, harmless, and honest responses.
Okay, a focus on safety there.
Exactly. And finally, you can't ignore Microsoft Copilot. This is significant because it integrates the power of OpenAI's GPT models directly into Windows, the Edge browser, and the entire Microsoft 365 suite: Word, Excel, PowerPoint, Teams. It's embedding AI directly into the daily workflows of hundreds of millions of users worldwide.
Okay, so beyond words, visual media has seen perhaps the most eye-catching transformation. We're truly in the dawn of AI art and video, it really feels like. The ability to simply describe an image and have it appear is still, well, mind-blowing.
You're right. Perhaps no application of generative AI has captured the public imagination more vividly and immediately than the creation of visual media. Text-to-image models can translate a simple written description into a rich, detailed, and often stunningly beautiful image in seconds. It's fundamentally opening up new frontiers for art, design, and visual communication. It's like having a hyper-realistic painter who can work at the speed of thought.
So how are artists, designers, and even marketers leveraging these new digital canvases? What are the practical uses?
Well, for artists, illustrators, and designers, these tools have rapidly become powerful creative assistants for art and illustration. They can be used to rapidly generate concept art for films or video games, create unique and striking illustrations for articles or books, or explore novel visual styles that would be incredibly time-consuming to produce by hand. The process is often highly iterative. The artist refines their prompts, guides the AI toward their desired vision. It's a collaboration.
Right, guiding it.
For marketing and advertising, where the demand for compelling visual content is just insatiable, generative AI allows teams to quickly create a wide variety of visual assets for social media campaigns, advertisements, websites, product mock-ups. This dramatically accelerates the content pipeline and allows for unprecedented levels of personalization in ad campaigns.
And it sounds like it's also transforming how products and even physical spaces are designed initially.
Absolutely. In fields like product design, architecture, industrial design, these text-to-image models serve as remarkably powerful prototyping and design visualization tools. A designer can describe a complex concept in words like a sleek, ergonomic office chair made of recycled aluminum and light wood in a bright, airy office setting, and receive multiple visual prototypes or renderings in mere seconds. This drastically speeds up the brainstorming and ideation phase before any physical prototyping even begins.
Speeds things up dramatically.
And finally, video generation is still an emerging capability, but it's incredibly exciting and hints at a future transformation. Tools are beginning to appear that can generate short, high-quality, and surprisingly coherent video clips from just a simple text prompt. This has the potential to revolutionize filmmaking, animation, advertising. But, of course, it also raises significant concerns about the potential for realistic deepfakes.
Yeah, that's the flip side. What's truly fascinating here is how quickly these tools move from being just a novelty to practical application, especially in creative industries. The source mentioned this concept of denoising an image from pure static. That's a beautiful analogy for how some of these models work, isn't it?
It is. The visual generation space is primarily driven by two key underlying technologies. There are the generative adversarial networks, GNs, which were that earlier pivotal breakthrough enabling highly realistic images. And more recently, diffusion models. These are fascinating. Diffusion models work by starting with an image that is pure random noise, just static, and then iteratively refining it step by step, gradually denoising it in a way that moves it closer and closer to the user's text prompt until a coherent and often stunning image emerges. It's like sculpting from noise.
Wow.
As for popular tools, DALL-E from OpenAI was one of the first text-to-image models to gain widespread public attention. It's now conveniently integrated into ChatGPT.
Easy access.
Yep. Midjourney is a huge favorite among artists, known for its highly detailed, artistic, and often kind of ethereal, stylized images. What's insightful about Midjourney is how it's not just generating visuals. It feels like it's pioneering a distinct visual language that's shaping a whole new aesthetic in digital art, often dictating trends across platforms.
Interesting, creating its own style.
Yeah. Stable Diffusion from Stability AI made waves because it was released as open source. This allowed a global community of developers and artists to build a vast ecosystem of custom models and applications around it, significantly accelerating innovation and making the technology incredibly accessible.
Open source is powerful.
Hugely. Adobe Firefly is notable because it's integrated directly into Adobe's professional creative suite, Photoshop, Illustrator, etc. And they specifically state it was trained on licensed stock images and public domain content, which they claim makes its output commercially safer and less prone to copyright issues, a big concern for professionals.
Like copyright thing.
And then there's Sora from OpenAI, the next-generation text-to-video model. The demos have shown stunningly realistic and remarkably coherent video clips up to a minute long. It signals a major disruption potentially on the horizon for visual storytelling and media production. Still early days, but wow.
Man, from writing a novel to scoring your own short film, these tools are putting incredible creative power into the hands of pretty much anyone. It's wild to think how accessible these formerly specialized crafts are becoming. That leads us right into the algorithmic composer. How is AI impacting music and audio creation?
Yeah, the realm of sound has also been profoundly touched by the generative wave. AI models are now capable of composing original music, generating realistic sound effects, and creating high-quality, expressive voiceovers. It's providing unprecedented new tools for musicians, podcasters, filmmakers, game developers, really anyone working with audio. It's democratizing sound production in a big way.
So how are people actually using AI to make music or create other audio? What are the use cases?
Well, for music composition and production, AI music generators can create original, royalty-free background music tailored to very specific needs. A YouTuber, for example, could generate a custom soundtrack for their video by simply specifying the desired genre, maybe lo-fi hip-hop, a mood like calm and focused, and a specific duration.
No more searching for royalty-free tracks for hours.
Yeah. Exactly. It provides an incredibly efficient and cost-effective alternative to expensive and time-consuming music licensing. For songwriting assistance, these tools can act as an invaluable creative spark for musicians and producers. An AI can quickly generate a novel chord progression, maybe a catchy melody, or even a full instrumental track based on a simple prompt. This helps artists overcome creative blocks or explore entirely new musical directions they might not have conceived of on their own.
So it's like a muse on demand.
Kind of, yeah. Some advanced tools can even generate complete songs, including lyrics and vocals from just a simple idea or theme.
For songs.
Yeah.
Wow. And voice generation, too, it has become incredibly realistic. It's getting harder and harder sometimes to tell if it's a real person speaking or an AI.
That's very true. The technology extends beyond just music to all forms of audio. Voice and audio generation through advanced text-to-speech, TTS models, like the ones used for this very deep dive potentially, can generate incredibly realistic and expressive voiceovers for audiobooks, virtual assistants, educational content, accessibility tools, complete with nuanced intonation and emotion.
Uh-huh. Some sophisticated tools can even generate vocal melodies for song prototypes, allowing a songwriter to hear their lyrics sung even if they don't have a singer handy, or create custom sound effects for video games and films based on a simple description, like footsteps on gravel, significantly speeding up audio post-production.
What are some of the popular tools that our listeners might encounter or want to experiment with in this rapidly evolving space? It seems like new ones pop up all the time.
It is evolving with remarkable speed. Suno is widely regarded as a leader right now in text-to-song generation. It's capable of creating complete 2-minute songs, lyrics, vocals, full instrumental backing from surprisingly simple text prompts. It's quite astonishing.
I've heard about Suno, yeah.
Udio is a direct and strong competitor to Suno, offering similar full song generation capabilities with really impressive quality. Muvert focuses more specifically on generating high-quality, royalty-free background music and soundtracks for creators. It allows users to specify exact durations and offers an API for seamless app integration, making it good for developers.
More for background stuff. Yeah. And Music Effects from Google, which used to be called Music LM, is noted for its high fidelity in matching the generated audio to the nuances of the user's text prompt. It seems to excel particularly at creating detailed and evocative instrumental music.
It's truly incredible how these tools are putting profound creative power into the hands of pretty much anyone, whether it's writing a novel or scoring your own short film. This really democratizes creativity in a way we've never seen before.
Okay, now, moving to a hugely impactful area, coding. How is generative AI becoming the coder's co-pilot? This seems massive.
You've hit on a critical point. One of the most economically significant and, frankly, transformative applications of generative AI is undoubtedly in software development. AI-powered coding assistants are being integrated directly into the developer's workflow, acting as an AI pair programmer that can help write, debug, and explain code. It's leading to substantial gains in efficiency and productivity. It's fundamentally changing the nature of programming itself. This is a total game changer for anyone in tech, right?
Yeah.
I mean, imagine how much faster and more efficient development can be when you have an AI pair programmer always at your side, ready to help.
It genuinely is. The most common use case, and one that developers seem to adopt really quickly, is code generation and auto-completion. A developer can simply write a comment in their code editor describing the function they need, like, hashtag function to fetch user data from an API and parse the JSON response. And the AI assistant will often generate the complete functional code for them.
Just from the comment.
Often, yeah. It also provides real-time, context-aware suggestions, auto-completing single lines, or even entire blocks of code as the developer types, significantly accelerating the writing process.
And what about those incredibly frustrating moments trying to find a tiny bug hidden in thousands of lines of code? Can it help there?
Oh, yeah. That's where debugging and error analysis becomes invaluable. When faced with a perplexing bug, a developer can paste the problematic code into the AI assistant and ask it to identify the error. The AI can often pinpoint the exact issue, explain the underlying logic flaw, and suggest a corrected version of the code. It drastically reduces the time spent troubleshooting.
That alone sounds worth it.
Definitely. These tools also prove immensely helpful with code explanation and refactoring. Modern code bases can be vast and complex, right? An AI assistant can analyze unfamiliar code and provide a natural language explanation of what it does, saving hours of deciphering. It can also help restructure existing code refactoring to improve its readability, efficiency, or maintainability without altering its external behavior. This makes code easier for teams to manage over time.
So it's not just about writing code faster, but also understanding it better and keeping it clean and maintainable in the long run.
Exactly. And for new developers entering the field, or even experienced ones learning new things, these tools act as powerful assistants for learning and documentation. They can serve as interactive, on-demand tutors for new programming languages or frameworks. A developer can ask specific questions, request code samples for particular tasks, and get instant context-rich explanations, really accelerating their learning curve.
Like a personal tutor.
Pretty much. They can also assist in generating comprehensive documentation for code, which is a critical but often tedious task for software teams. Good documentation ensures that projects are well understood and maintainable long-term. AI can help automate that.
What are the big players in this rapidly evolving space for coders? Who should developers be looking at?
The field of AI coding assistance is led by several prominent tools. GitHub Copilot, developed by GitHub in collaboration with OpenAI, is arguably the most prominent and widely adopted AI coding assistant right now. It integrates directly into popular code editors like VS Code and really excels due to its deep contextual awareness. It looks at the entire project a developer is working on to provide highly tailored suggestions.
Context is key there.
It is. Amazon Q Developer, which used to be called Code Whisperer, is AWS's direct competitor. It offers similar functionality with real-time code suggestions and integrated security stands. It's trained on Amazon's own vast internal code bases and is, unsurprisingly, deeply integrated with the AWS ecosystem, making it attractive for cloud developers using AWS.
Makes sense for AWS users.
Yeah. Tabnine stands out for its flexibility. It supports a wider range of code editors and, crucially, allows companies to train the model on their own private code repositories. This ensures adherence to company-specific coding styles and provides enhanced privacy for proprietary code, which is a big deal for many businesses.
Control over the training data.
Exactly. And finally, tools like Cursor and Zed represent maybe the next evolutionary step. They are AI-first code editors, where AI isn't just an add-on plugin, but a core, deeply integrated component of the development environment itself. It hints at a future where the line between the human developer and the AI assistant becomes increasingly blurred.
Okay, so across all these incredible applications we've talked about, language, art, music, code, is there a consistent market structure emerging? It seems like it's not just one giant company doing everything. How is the market shaping up?
You've observed a crucial pattern there. Yes, there's a very clear and consistent structural pattern emerging in the generative AI market, which we can think of as the generative stack. Understanding the stack is really revealing about how value is being created and captured in this new technological era.
Okay, the generative stack. Break it down for us.
Right. At the very bottom layer, you have the massive, capital-intensive foundation models. Think OpenAI's GPT-4, Google's Gemini, Anthropic's Claude. These are the general-purpose intelligence engines, the incredibly powerful, generalized models trained on those vast datasets we talked about. They're developed by a small number of large tech companies with immense resources, billions of dollars in compute and talent.
Okay, so those are the colossal foundational brains that do the heavy lifting, built by the giants. What's the next layer up?
The next layer up is the platform API layer. This is where companies like OpenAI, Google with their Vertex AI platform, Anthropic, and others provide application programming interfaces, or APIs. These APIs allow other developers and businesses to access and build upon the power of their foundation models without having to train one from scratch, which is prohibitively expensive for most. This layer makes the core AI capabilities widely available as a service.
Like plumbing almost, letting others tap into the power.
Exactly like plumbing. This has then given rise to the top layer, a vibrant and rapidly expanding ecosystem of specialized application tools. These are thousands of innovative companies and startups that use the underlying APIs from the platform layer to create tailored end-user solutions for specific industries or tasks. Think of tools like Jasper for marketing copy generation, or CodeWP specifically for WordPress development, or specialized medical AI assistants focusing on diagnostics.
Ah, so specialized tools built on top of the big engines. That makes so much sense. It sounds a lot like how cloud computing providers like AWS or Azure enable countless software-as-a-service apps that we use every day.
It's a very strong analogy. The parallels to the evolution of cloud computing are striking. AWS, Azure, Google Cloud provide the infrastructure, enabling a whole universe of SaaS applications.
So the crucial insight here is that the real long-term value isn't just in owning the biggest, most powerful foundation model, but perhaps even more so in cleverly applying that power to solve specific, real-world problems.
Precisely. What's truly fascinating here is how this generative stack isn't really unique to AI. It's a classic blueprint for how all major technological shifts tend to mature. It creates opportunities at every layer, from the raw infrastructure, the foundation models, to the platforms, the APIs, to the end-user applications. This insight reveals that the real long-term value isn't just concentrated at the bottom with the biggest models. Huge value is being created by the ingenuity of applying that foundational power to solve specific, tangible problems in countless industries. It means innovation can happen not just at the core model level, but maybe even more dynamically by building smart, user-centric applications on top of these existing powerful models.
Okay, so we've covered what generative AI is, how it works under the hood, its long and surprising history, and its incredible current applications across so many different fields. Now let's zoom out and talk about the big picture. What are the profound promises and the significant perils as we navigate this new generative age? This feels like the really crucial part.
It really is. The rise of generative AI is more than just a technological development. It is, without exaggeration, a societal event with far-reaching consequences that will touch pretty much every aspect of human life. As these increasingly powerful tools become more deeply integrated into our economies, our cultures, our daily routines, it's imperative to move beyond simply understanding their capabilities and instead confront their profound and often paradoxical implications. Generative AI presents a classic double-edged sword, immense promise alongside a complex landscape of significant perils. We have to look at both sides.
Okay, so let's start with the bright side then.
Hmm.
What are the big promises it holds for us collectively? Where's the upside?
The potential benefits are truly vast and exciting. The most immediate and measurable impact is the dramatic boost to productivity and efficiency. Generative AI can automate and significantly accelerate a wide range of knowledge work tasks, handling routine emails, summarizing lengthy reports, drafting presentations, writing boilerplate code, all the stuff that bogs people down.
Freeing people up.
Exactly. This frees up human workers from tedious, repetitive activities, allowing them to focus on higher-value strategic thinking, complex problem-solving, and crucial human-to-human interaction where, empathy and nuanced understanding are paramount. The economic impact projected by some analyses is just staggering. McKinsey, for instance, suggests it could add somewhere between $2.6 trillion and $4.4 trillion annually to the global economy.
That's an almost incomprehensible number. Wow. And it's not just about doing existing things faster, right? It seems like it's also about unlocking entirely new ways to create, isn't it?
Exactly. Beyond mere efficiency, it serves as a powerful engine for enhanced creativity and innovation. Generative AI is a true creativity multiplier. By serving as that tireless brainstorming partner we talked about, it can help individuals and teams generate a wider range of ideas, explore more creative avenues, and overcome mental blocks like writer's block or design paralysis.
Mm-hmm.
In fields ranging from graphic design to architecture, marketing, even engineering, AI can rapidly produce diverse prototypes and variations, allowing for a far more expansive and fluid creative process that was previously just impossible due to time or resource constraints. Another profound promise is hyper-personalization. The ability to generate unique content in real time allows for a level of personalization previously unimaginable at scale.
Tailored everything.
Pretty much. In e-commerce, this means tailored product recommendations that feel genuinely individual. In education, it promises adaptive learning paths that adjust to each student's pace and style. In healthcare, it could lead to highly personalized treatment plans based on an individual's unique biological data. This move towards hyper-personalization has the potential to dramatically improve user experiences and outcomes across countless sectors. And finally, it's accelerating science at an unprecedented pace. Well, in the life sciences, for instance, AI models are designing novel proteins and molecules, drastically accelerating drug discovery and material science. DeepMind's AlphaFold, which revolutionized biology by accurately predicting protein structures, is a prime example of this. By analyzing incredibly complex data sets, generating hypotheses, and simulating intricate systems, generative AI is becoming an indispensable tool for researchers, dramatically speeding up the pace of scientific discovery and our understanding of the universe.
Yeah, okay, the potential is clearly enormous.
Yeah.
But you said it's a double-edged sword, so it's clearly not all sunshine and roses. What are the major perils? The serious risks and challenges we need to be acutely aware of and actively address.
Right. Alongside this immense promise lies a landscape of formidable and multifaceted challenges that we absolutely must confront head-on. Perhaps the most fundamental limitation, which we touched on with the blurry JPEG analogy, is inaccuracy and hallucinations.
Right, making stuff up.
Exactly. Because these models predict statistically likely words or patterns rather than possessing a true understanding of facts or truth, they can confidently generate outputs that sound perfectly plausible but are factually incorrect, internally inconsistent, or completely nonsensical. Relying on AI-generated content without rigorous human verification is perilous, especially in high-stakes fields like medicine, law, or finance, where a confident yet erroneous output could have severe, real-world consequences, misdiagnoses, bad legal advice, financial ruin.
That's scary. And the big question everyone asks, perhaps most anxiety-inducing for many, job displacement. What's the realistic outlook there?
Yeah, that's a central concern. Job displacement and economic disruption. The sheer power of generative AI to automate and accelerate a wide range of knowledge work tasks raises significant questions about the future of employment. While many argue it will largely augment human workers rather than replace them outright.
Which we discussed.
Right. But it is undeniable that the nature of many jobs will fundamentally change, and some roles, particularly those highly susceptible to automation, may be significantly reduced or even eliminated. This could lead to significant economic disruption and has the potential to widen the gap between high-skilled workers who can effectively leverage AI tools and lower-skilled workers whose tasks are more easily automated. It could exacerbate existing economic inequalities if we're not careful.
Okay. Then there's the incredibly complex and burgeoning issue of intellectual property and copyright. This seems like a legal minefield.
It absolutely is. These powerful models are trained on vast quantities of data scraped from the internet, much of which is copyrighted material, texts, images, music, all ingested without explicit permission or compensation to the original creators.
So they learn from copyrighted stuff.
Largely, yes. This raises thorny legal and ethical questions. Who actually owns the AI output? Does an AI-generated image that closely mimics a specific artist's style constitute copyright infringement? How should creators whose foundational work forms the very basis of these models be fairly compensated, if at all? These are deeply complex legal and societal issues that are only just beginning to be addressed through litigation and new legislative efforts. There are no easy answers yet.
And what about the potential for intentional misuse? The ability to create convincing, fake content that has some very alarming implications, doesn't it?
That's a major and very serious concern. Malicious use, misinformation, and deepfakes. The very same technology that fosters incredible creativity can also be weaponized. Generative AI dramatically lowers the cost and the technical skill required to create highly convincing misinformation, targeted propaganda, and sophisticated fraudulent content at a massive scale.
Easier for bad actors.
Much easier. Think of incredibly realistic deepfake images, audio, and videos that could be used to create fake political endorsements, spread widespread disinformation campaigns to manipulate public opinion, or engage in malicious personal harassment. The potential for these tools to erode social trust, sow discord, and even undermine democratic processes is one of the most critical and pressing risks associated with the technology that we face today.
So, beyond those immediate paradoxes of productivity versus displacement or creativity versus misuse, it feels like there are deeper ethical considerations to grapple with, especially around bias and accountability. These seem less about what the AI does and more about how it's built and who built it.
Precisely. These are not simply technical bugs that can be easily fixed in the code. They are inherent properties of the technology stemming directly from how it's constructed and, most importantly, the data it learns from. Navigating the generative age responsibly requires confronting these issues head-on. First, we have the bias in the machine.
The cultural mirror idea again.
Exactly. Generative AI models are, by their very nature, a reflection of the human-created data they are trained on. And unfortunately, as we know, that data is often rife with existing societal biases related to race, gender, culture, language, socioeconomic status, ability, you name it.
It's all in there.
It's all in there. Consequently, AI models inevitably learn, reproduce, and sometimes even amplify these harmful stereotypes. For instance, an image generator asked for a CEO might predominantly show images of white men, or a language model might associate certain nationalities with stereotypical jobs, reinforcing problematic societal norms.
And that can have real consequences.
It can lead to deeply discriminatory outcomes in critical applications like automated resume screening, loan application approvals, or even medical advice where an unseen bias can have real-world detrimental effects on people's lives. Mitigating this is profoundly difficult. It requires not just technical fixes, but diverse data sets, rigorous auditing and testing for bias across various demographics, and a conscious, ongoing commitment to inclusive representation in every stage of development.
And what about understanding why an AI made a certain decision or generated a particular output? That black box problem seems like a major hurdle for trust.
That's a huge challenge, often referred to as the black box problem. Transparency and accountability. Modern neural networks, with their billions or trillions of intricately interconnected parameters, are incredibly complex systems. They're often black boxes in the sense that even their creators can't always precisely explain why a model produced a particular output or arrived at a specific decision.
Even the makers don't fully know.
Often, they can't trace the exact reasoning path. This interpretability challenge poses a major obstacle to building trust and ensuring accountability. If an AI model denies someone a loan, flags them in a security system, or provides a faulty medical diagnosis, the inability to trace its exact decision-making process makes it incredibly difficult to debug the system, challenge or appeal the decision, or assign responsibility for potential harms. In high-stakes domains, this lack of transparency is a critical barrier to safe and ethical deployment and raises significant questions about legal and moral responsibility.
Beyond the immediate impact on individuals making decisions, there are also broader, real-world costs to consider, like privacy, security concerns, and even the environmental impact. These feel like larger systemic issues we need to think about.
They are, and they represent the broader human cost: privacy, security, and environment. For privacy, because models are trained on vast internet datasets, there's a risk they can inadvertently memorize and then regurgitate sensitive personal information that was publicly available but maybe not intended for such use, like names, addresses, private conversations, medical details. This creates a significant risk of privacy breaches and identity theft.
Yikes.
For security, the technology provides powerful new tools for malicious actors. It can be used to craft highly convincing phishing emails with perfect grammar, generate novel malware code, or help identify and exploit software vulnerabilities at an unprecedented speed. It significantly lowers the barrier for sophisticated cyber attacks and makes them harder to detect.
Okay. And the environment, how does that fit in?
And for the environmental cost, it's a stark reality we're only just beginning to really grapple with. Training a single large foundation model can consume an enormous amount of energy, as much as powering thousands of homes for a year. It requires massive data centers that gobble up electricity and vast amounts of water for cooling. This significant carbon footprint presents a critical challenge for sustainable AI development, urging us to consider the real-world resource drain behind the digital magic. It's not free.
Not at all. All of this, the bias, the black box, privacy, security, environment, it points to a growing, urgent need for clear rules, guidelines, and even laws, doesn't it? The call for global governance seems louder now.
Absolutely. In response to this complex web of risks and profound societal implications, there is a growing global consensus on the urgent need for robust governance and regulation. This involves governments, industry leaders, civil society, academics, all working together to establish clear frameworks for the responsible development and deployment of AI.
What kind of rules are needed?
Key areas of focus include creating comprehensive rules for data privacy and data governance, demanding greater transparency and accountability from AI developers regarding their models' behavior, establishing clear liability for harms caused by AI systems, and creating effective mechanisms to protect against malicious misuse. Legislative efforts like the European Union's pioneering AI Act are significant examples of this global push to create binding rules to try and ensure that AI is developed and deployed in a way that is safe, trustworthy, and aligned with fundamental human and democratic values.
And this leads us to what sounds like maybe the deepest philosophical issue of all, the alignment problem. It's often discussed in technical circles, but the source suggests it's much, much more than just a technical puzzle.
It is perhaps the most profound challenge facing AI development, and maybe humanity. A key technical goal in the field is the alignment problem, the daunting challenge of ensuring that an AI's behavior consistently aligns with human goals and values. Techniques like reinforcement learning from human feedback, RLHF, are a direct, technical attempt to shape the model's outputs to be more helpful and harmless, as we discussed.
Right, trying to steer it.
But the seemingly neutral technical goal is, in reality, a deeply philosophical and political one. The critical question immediately becomes, whose values should the AI be aligned with? The values of the engineers in Silicon Valley who build it, the values of the government that regulates it, the values of the specific culture in which it is deployed. There is no single monolithic set of human values that applies universally.
That's a huge problem.
It is. The very act of aligning an AI is an act of encoding a specific worldview, often that of the dominant culture in which it was created. This worldview can then be subtly or overtly imposed on users globally, risking the marginalization of local languages, cultures, and norms. Therefore, the alignment problem for AI is not a problem that can be solved by computer scientists alone. It is, in essence, an alignment problem for humanity itself. It forces us to have explicit, difficult, and inclusive public debates about what kind of future we collectively want to build and what core values we want to embed in these powerful new technologies. There are no easy answers, and understanding this inherent complexity is the final step in moving from being a mere novice user to an informed, responsible citizen of the generative age.
That's a profound and, frankly, necessary thought to really sit with. So looking beyond the immediate challenges and the current capabilities we've discussed, what do the next horizon hold for generative AI? Where is this all heading in the coming years based on current trends?
Well, while the current capabilities of generative AI are already transformative and really pushing boundaries, it's important to remember that this technology is still very much in its infancy. The pace of innovation in this field is just relentless. And a number of key trends are rapidly emerging that will fundamentally shape the next horizon of this revolution, moving us further toward a future of increasingly deep and seamless human-AI collaboration.
Okay, what's the first big trend we should expect to see become more widespread? What's coming next?
The first generation of popular generative tools largely operated within a single modality, right? You had models for text, models for images, models for audio. The future, however, is definitively multimodal.
Multimodal, handling multiple types of data at once.
Exactly. The next wave of foundation models is being designed from the ground up to understand, process, and generate content seamlessly across multiple formats at once. This means you'll be able to interact with a single AI system using a combination of text, images, voice commands, even video inputs simultaneously.
Wow. Give me an example.
Okay, so you might provide a text script for a scene, a reference image to define the visual style, and maybe a short music clip to set the mood. Then you prompt the AI to generate a complete coherent video scene that intelligently integrates all of these disparate elements. Multimodality will move from being a niche feature to a standard expectation, enabling far more complex, intuitive, and natural creative and informational workflows.
And the idea of AI becoming more proactive, less just sitting there waiting for a prompt. That sounds almost like science fiction, like HAL 9000 or something.
Hopefully less sinister. But yes, it's quickly becoming reality. That's the trend of hyper-personalization and agentic AI. The technology is evolving from being merely a responsive tool that passively waits for your prompt to becoming a proactive assistant or agent that can anticipate your needs and take initiative on your behalf.
An agent. Okay.
This concept envisions AI systems deeply integrated into our digital lives, capable of understanding your personal context, specific goals, and individual preferences. These agents will be designed to perform complex, multi-step tasks autonomously. For instance, you could potentially just ask an AI agent, plan a weekend trip to Paris for my anniversary next month, keep the budget under $2,000, and book the flights in a highly rated hotel near the Louvre.
And it would just do it.
The goal is, yes, the agent would then proactively research flights, compare hotels, check reviews, make the bookings, intelligently interacting with various other software and services online to accomplish the entire goal, freeing you from the numerous steps involved. This shift toward proactive, increasingly autonomous agents promises an entirely new level of hyper-personalized assistance and task management.
That's wild. An AI that understands your life enough to plan an entire trip.
Yeah.
That raises questions about autonomy again, though. And what about how these tools will be distributed? Is it still going to be just a few huge models controlling everything, or will we see something else?
That's a critical question regarding autonomy, which definitely ties back to the governance and alignment discussions we just had. The level of autonomy granted to these agents will be a key area of development and, hopefully, careful regulation. As for distribution, as the underlying foundation models become even more powerful and, crucially, more accessible through things like open source initiatives and easier APIs, two parallel trends will likely accelerate: democratization and specialization.
Okay, democratization and specialization.
For democratization, major companies are investing heavily in creating even more user-friendly interfaces and tools. This will allow non-technical users in virtually every field, marketing, sales, education, law, healthcare, to leverage the profound power of generative AI in their daily workflows without needing to write a single line of code. It truly puts advanced AI capabilities into everyone's hands.
Making it easier for everyone.
Right. And for specialization, the increasing availability of powerful open-source models like Meta's Llama series and easy-to-use fine-tuning platforms will fuel an explosion of smaller, highly specialized models tailored for extremely niche industries and tasks. We will see models fine-tuned specifically for, say, legal document analysis in a particular jurisdiction, or for detailed medical diagnostics for a specific condition, or for highly precise financial reporting according to certain regulations, and countless other industry-specific applications. They'll become incredibly powerful within their defined domains.
Also, both wider access and deeper expertise. And what about the hardware itself? We mentioned the environmental cost. We're already pushing current computers to their absolute limits with these massive models. Does that need to change for this future to happen?
That's an extremely crucial point. Today's generative models are largely running on hardware CPUs and GPUs that, while powerful, was not originally designed from the ground up for their unique and incredibly demanding computational requirements. This is inherently inefficient and contributes significantly to the technology's substantial energy consumption.
Right.
Therefore, leaders in the field are calling for and investing in a new generation of AI-first hardware. More powerful, far more energy-efficient specialized chips like Google's tensor processing units, TPUs, and next-generation GPUs, specifically architected to handle the massive parallel computations required by AI efficiently.
Chips built just for AI.
Exactly. It may also lead to entirely new categories of AI-first devices. Instead of primarily interacting with AI through a phone or laptop screen, we might see personal AI companions that are wearable or ambient, seamlessly integrated into our environment. Think devices capable of understanding our emotional state and personal context through new kinds of sensors, providing a much more integrated and intuitive form of assistance throughout our day.
So, what does this all mean for us? It really sounds like we're truly just at the beginning. The idea of AI agents planning our entire trips or entirely new hardware built just for AI,
Yeah.
it's genuinely mind-boggling to consider the implications.
It is absolutely mind-boggling. And if we connect this to the bigger picture, all these trends, multimodality, agentic AI, specialization, new hardware, they point toward a future defined not by machines replacing humans, but by a new symbiotic form of partnership that some have termed human-AI co-intelligence.
So intelligence, I like that.
In this vision, AI serves as an incredibly powerful, intelligent extension of human intellect and creativity. The human's role shifts from being the sole creator or doer to becoming the director, the curator, the prompter, the critical thinker who guides and refines the AI partner's output. The synergy between human intuition, judgment, and values, combined with AI's vast knowledge, incredible speed, and unparalleled pattern recognition ability, will enable us to tackle problems and achieve creative feats that were previously unimaginable for either humans or machines alone. This collaborative future is one of human augmentation on an unprecedented scale, not, hopefully, obsolescence. #outro.
Wow. This deep dive has really shown us that generative AI isn't just a fleeting trend or some recent fad. It's a fundamental paradigm shift that's truly been decades in the making, from its surprising winding history to its rapidly expanding present-day capabilities and the profound questions it raises about our future. There's truly so much to unpack and keep exploring.
And for you, our listener, as you embark on your own journey into this new age of human-AI co-intelligence, the key is really to engage actively, curiously, and perhaps most importantly, critically. Our foundational guide, Generative AI Novice Introduction, gives us a fantastic roadmap for that active engagement.
And you've really got to try some of these tools. The hands-on experience is truly the best way to understand their power and their quirks. The source suggests a great way to start is small. Experiment with free tools like various chatbots or image and music generators on low-stakes projects. Try drafting a simple email, generating a unique birthday card, or even composing a short fun tune just to see what happens. Then the second crucial step is to learn to prompt effectively. This art of crafting clear, specific, and creative instructions, often called prompt engineering, is really key to unlocking high-quality results from these models. Don't be afraid to experiment with different phrasing, providing more context, and iteratively refining your prompts to get what you actually need. It takes practice.
It does. And critically, always remember to stay critical. Never take AI output at face value, especially when it comes to factual claims. Always assume there might be inaccuracies or biases present in the generated content. Fact-check any factual claims with reliable, independent sources. Don't just trust the AI. And be mindful of stereotypes that might emerge in the output. Treat it as a powerful, incredibly useful, but still fundamentally flawed tool, not some infallible oracle.
Good advice.
And as we've explored throughout this deep dive, The trajectory of this transformative technology isn't predetermined. It's being actively shaped right now by human choices, by the data we feed it, by the systems we build around it, and by the regulations we put in place. This raises a final important question for all of us to consider. If generative AI acts as that cultural mirror, reflecting the human data it was trained on, what kind of reflection do we, as a society, collectively want to see when we look into that mirror a decade from now? What do we want it to show us about ourselves?